Hello, so my name is Marwan, and we will begin with the introduction. The elevator system is a common real world example of an embedded system that operates based on defined states and transitions. It serves to transport people or goods between floors in a building efficiently and safely. The elevator operates through a controller that responds to the user input and system conditions, such as the current floor or the door status. It transitions between different states, such as idle, moving up, moving down, door opening, and door closing. The system must handle requests from both inside the elevator and from outside the different floors. The FSM is ideal for modeling this system due to its event driven nature and predictable transitions. This project aims to simulate the logic of such a system using a finite state machine for better understanding and optimization.
Alright, for the problem, we will discuss about three main points here. So first, I will go with the problem statement that we came up, which is designing an elevator control system that efficiently and safely responds to the cabin and button inputs for better movement and direction, and also door operation to a reliable finite state machine, also known as the FSM. Right. For the first point, why is the need of efficient elevator control, especially in the multi-level story buildings that has 30, 40, 50 story? It is very essential for transporting people and also logistics or goods inventory. What will happen without an optimized control system? Waste time of responding to the user requests, it will cause delays or longer waits, and also leads to frequent unnecessary stops. The next point, what is the common problem in the elevator system that we found right now? First, unpredictable transition between floors due to poor logic in the system. Second point, inefficient handling of simultaneous requests. Example, someone pressing up and down simultaneously at the same time. So when there's a poor logic, there will happen a inefficiency. Third point, unclear door management where door opens or close prematurely and stay opens too long. And also no prioritization, for example, for emergency part. And for the third point here, why we choose a finite state mission FSM? First, provide structured way to manage transition based on events, ensure the elevator reacts consistently and predictably. Third one, simplifies debugging and logic optimization for more efficiency. And the last point, it helps manage complex interaction like door opening only after elevator stops, preventing movement while doors are open, or prioritizing requests based on direction and current state. That's all for the problem part. That's all from me, Safiqur Rahman. Thank you so much.
Assalamu alaikum. I'll be talking about the system diagram of how the elevator works. So firstly, it'll start off at idle, and it's basically awaiting instructions from people. And once it receives an instruction, it'll move to the designated floor or the person where the person is staying at, and it'll open its doors and either prepare to move up or down based on the person's instructions. And once it's received, it will close the door, move to the designated floor, and then it'll stop at it and open its doors, and it'll be at the floor. Once it's done, it will check for the next order, and if it receives an order based on either moving up to the floor or below, and it will go as so in the diagram. If not, it'll go back to idle, as mentioned in the diagram again. All right, thank you. Assalamu alaikum. So I'll be talking about the finite state machine diagram for an elevator. So let's start off with from the initial state, which is idle. This is where the elevator waits for any request, and it's from a user pressing a button or calling it from another floor. Once it's received, it will prepare to move either up or down, as shown below. And in these states, the door closes and the elevator gets ready to move. After that, the elevator transitions to the moving state. This means it's actively traveling towards the requested floor, and once it continues in the state, it would reach the desired floor. From there, it will typically move into other states like stopping, door opening, or checking for new requests. Checking for new requests is until it finished its original request, and if it's fulfilled that request, it will return to the idle state, waiting for further instructions. This is more or less similar to the previous diagram, except this is in the form of a FSM diagram.
Hello, here I am. My name is Danish Harith bin Ahmad Nizam, and I will be presenting about the conclusion of our assignment, our embedded assignment. So for this assignment, I'll be briefly present our work on the elevator control system that using FSM, which is a finite state machines. So first of all, our goal in this project is actually was to design a highly reliable and safe elevator system, since it's actually quite common in our modern day life. It's really crucial to bring people in one level to another level. So actually the core challenging in handling complex interaction like a button press, the movement of the lift itself, and the door operation simultaneously without error. So we can say that the system is actually quite complex, but we do need to create it without any errors that can bring maybe some damage to the leaf itself, and maybe can harm the humans itself. So to achieve this, we had developed a system based on the FSM, and as mentioned from our friend itself, Manas, he mentioned about the FSM, and he showed that how the elevator transition precisely between the states, like idle, the moving, or doors open. So based on the specific event. So actually this FSM approach will ensure the elevator behave exactly as expected, because it can preventing a common issue like doors opening while moving, or even unresponsive control. Maybe some buttons that are really crucial, like emergency button or stop button. So it's the key to making the system predictable, safe, and easy to manage. So what can I summary from our project is actually our project also demonstrate that FSMs are an incredibly effective way to build a smart and reliable elevator control. So we solve the problem where we create a consistent and error in a free system, and FSM are key is the provide the perfect logic to manage all the elevator action, and the smooth and safe ride is actually this design will ensure doors open and close correctly, movement is controlled, and the elevator always know what to do next. And what I add on in this presentation slide is also the real world impact. This approach is fundamental for all complex automated systems, and we also had a benefit achieved where efficiency, it is faster, smarter, responsive to call. In terms of safety also, it's prevent the dangerous situations, and in terms of reliability, it's also a predictable and consistent operations. Thank you. I think it's all from me. Thank you.